For the next part, the reasons of deviation. One of the common sources of irreversibilities is fluid friction. It causes the pressure drops in the boiler, the condenser, and the piping between various components. As the result, steam leaves the boiler at a lower pressure. Pressure at the turbine inlet is somewhat lower than that at the boiler exit due to pressure drop in the connecting pipes. Usually the pressure drops in the condenser is very small. To compensate these pressure drops, the water must be pumped to a sufficiently higher pressure than the idle cycle calls for. And then this requires a leisure pump and leisure work input to the pump. Further, second common sources of irreversibility is heat loss to the surroundings. To maintain at the same level of net work output, more heat needs to be transferred to the steam in the boiler to compensate for these undesired heat losses. As a result, cycle efficiency is decreased. Of particular importance are the irreversibilities occurring within the pump and the turbine. Pump requires a greater work input and a turbine produces a smaller work output as a result of irreversibility. Under ideal conditions, the flow through these devices is isentropic. So that means S1 equal to S2, S3 equal to S4, and then this is the formula of isentropic efficiency. Graph the effect of pump and turbine irreversibilities on the ideal Rankine cycle. Another factors need to be considered in actual condensers. For example, the liquid is usually subcooled to prevent the onset of cavitation, the rapid vaporization and condensation of the fluid at the low pressure side of the pump impeller, which may damage it. Additional losses occur at the bearing between the moving parts as a result of friction. And then steam that leaks out during the cycle and air that leaks into condenser represent two other sources of loss. Finally, the power consumed by the auxiliary equipment such as fans that supply air to the furnace should also be considered in evaluating the overall performance of power plants. This is the graph deviation of actual vapor power cycle from the ideal Rankine cycle.